This spectrometer app measures different wavelengths of light going from blue to red, in this case for white light, and you can see we've got a nice white spectrum there. If we change the colour of the lamp to red, you can see that we've got all the peak wavelengths in the red part of the spectrum at longer wavelengths. If we change the colour light to green, you'll see that peak just shifted, it's just picking up on the green there. It takes a while to respond and count all the different wavelengths, so now it's peaking in the green part of the spectrum, around about 500 nanometers of wavelength. And then if we change it to blue light, then you can see that peak there now in the shorter wavelength blue area of the visible spectrum. So we're able to plot, using the spectrometer, all the different colours in the spectrum using this app. The lamp we've got here allows you to change the colours, and it does that by having different LEDs. In this case you can see that magenta is made of blue and red because of the two peaks. If we go to yellow, then you'll see that we start to get peaks in the green and the red parts of the spectrum. That's how the lamp makes up the yellow light that you see. If we replace the LED lamp with a cadmium vapor discharge lamp, then you can see that there's peaks coming up there for different key wavelengths which are characteristic of cadmium vapor. This is how we can identify the elements in stars. You can see this nicely with a second lamp. This time it's a sodium lamp, and sodium has a single wavelength here, and you can see that wavelength increasing as the sodium vapor light warms up. The setup we've got here is a filament lamp with a variable voltage to give us variable temperature on the filament. As we increase the temperature, you can see the light bulb starting to increase its brightness. It's also increasing the temperature of the tungsten filament. Initially there was some infrared, now we're getting a lot more actual visible red radiation, but as the voltage increases and the temperature increases, we're actually getting a greater irradiance, more energy, and the peak is actually moving towards the green and therefore giving us a much more broad white light spectrum. Just repeat that and you can see the amount of irradiance increasing as the filament gets hotter. Also watch that peak wavelength. It's currently in the red. As the light bulb turns to white, you can start to see the peak moving towards the green to the center of the visible spectrum.